big fires periodically. And sometimes the fire burns all the way down to mineral soil. I mean, even though, there's 10 feet of standing water there, it still burns right down to the mineral soil, burns all the peat and whatnot. So you can you can have serious fires in a very wet environment. Well, then we have bogs and fens, and people would normally call a lot of the wetlands on the Kenai bogs, but really, I don't think we have any true bogs here, and you'll see why in a minute. We have fens, and fens are fed by groundwater and runoff, and they're rich in minerals. They're very well fed, but bogs are just fed by rainwater, and rainwater does have some minerals in it, but very few, and so there are really very few plants that can live in a low nutrient environment, just fed by rainwater. So fens, we say, are mineral trophic because they're getting all these minerals, derived from the bedrock and the soil. Bogs are called ambitrophic or oligotrophic, meaning that they are essentially poorly fed. Well, there's kind of two basic processes that go on to form these fens and bogs. And one is the fairly normal process, and we'll look at this in more detail, but essentially you're starting with a wet spot. I mean, it might just be a little pond or a seasonally wet spot, but somehow vegetation is accumulating there, and over time peat forms. So what was open water, now becomes, land, and so that's called terrestrialization or infilling. And that's the very standard case on the Kenai. Now the opposite situation is where you actually have a wet spot developing on the land surface and collecting water, and then peat beginning to accumulate there. And that's called paludification or swamping of the landscape. And we don't really have much of that on the Kenai. I mean, I think I've seen this kind of around the edges of lakes in a few places where the sphagnum is starting to creep uphill a little bit, but basically our climate is way too dry here. But if you go to Ireland, on the other hand, you can see paludification going on full bore. So here is a typical history of what might be a bog in Ireland, and this is going to become a raised bog that actually is, well, in this case, going uphill. But we start with simply a pond and sediments, mud is accumulating in the bottom, and then around the edge of the pond, plants start to grow on the shore. And so this would typically be sedges and grasses and things like that. But notice that the vegetation is expanding out of the pond now, and it's actually growing into the forest. And here it's covered up with tree stump. So if we were to dig here, we'd actually dig down through peat and, find a buried stump. Now, we don't find that on the Kenai, and we'll talk a lot about that. But okay, so the process continues there, and sphagnum is expanding now into the woods more and more, covering up more stumps. And finally it's expanded here, and you can see that the slope of the peat surface is going uphill here. So you could see this maybe in southeast Alaska, where there are blanket bogs that go right uphill. Sphagnum moss is growing up through the forest and paludifying it. But this only happens in a quite wet climate. Okay, so here's what a wet climate looks like in Ireland. Most of the Ireland is this light pink, the second pink here, 800 to 1200 millimeters of water per year, and that translates into 31 to 47 inches. So 47 inches is like twice what Homer has. I mean, we are really in a dry rain shadow here of the Kenai Mountains, and we're kind of lucky to have all these wetlands and fens growing. I mean, the drainage is very poorly developed. Here, most of the peatlands are on the surface of the last glaciation, the Wisconsin glaciation, which climaxed about 20,000 years ago. So there has not been time for a lot of good streams to develop and drain the landscape well. And so there are all these depressions around that, water can accumulate and peatlands develop. But because the climate is getting warmer and drier, we are in a dangerous situation. I mean, we are really on the low end here of where it's possible to have peatlands. And if it gets any drier, we're going to start losing carbon. Well, okay, two types of succession of plant communities. Let me talk about the autogenic. This is kind of the automatic succession. This is what you would expect if you don't have fire, climate change, flooding, and so forth, messing with things. So this is just the natural order of things. So, one example that's quite common here, after a fire, we have birch and willows, aspen, cottonwood, and things like that come in very quickly after the fire. And then there are little spruce seedlings growing underneath those, broad leafy plants, but they're growing very slowly. But in time, the spruce, because they are shade tolerant, will grow up and overtop all of those green leafy things and shade them out. And then you'll have a mature spruce forest with not a lot of leafy plants underneath. And so that's kind of the normal autogenic succession here. Thinking about it in forests. Now, if we think about autogenic succession, starting with the pond, this is sort of the textbook example, and probably you've seen this in one form or another, starting with high school biology, that, well, okay, we've got a pond, and there's some aquatic plants, growing in the pond, and sediment starts to accumulate at the bottom. Now, some of this sediment is dust that's blown in and settles on the lake, but a lot of it is fish poop, for instance, and dead plant material that was growing, and that produces this mud, and the mud is called gitja. I should have that word. It's I think Swedish word. But when we core lake sediments around here, we see a lot of this rich organic mud it's kind of formless, but it's just the pieces of vegetation and the fish poop and dust, and of course the volcanic ash gets added to that here too. But then we get some plants that will grow on the bottom of the pond there that can grow fully underwater, and then we get some like water lilies that are rooted there and have their leaves up on the surface, and the mud is accumulating, the gitja is accumulating, and then we get to a point here where there's water here, but we're only talking about 2 or 3 inches, and so sedges would be a very typical thing we'd have growing here. And then we get to this point here where there may be pools of water, but there's hummocks and things like that, and This particular diagram doesn't show it, but sphagnum would be coming in here with the sedges as well. And then some shrubs start coming in, and leaf litter is accumulating here. And then finally we get a forest. Okay, so this is kind of the textbook example of the way that you get from a pond to a forest. Well, when I first started talking about the shrub and tree invasion going on the Kenai, people said to me, well, you know, that's just ordinary succession going on here. This is perfectly normal that we should see black spruce, you know, growing in these wetlands, and dwarf birch and so forth, blueberries, you know, I mean, that's just standard succession. And well, what I had to say is that this is true. That is the standard succession. But on the Kenai, we were stuck at this phase, this stage here, 6, you know, probably for 14,000 years. You know, we were stuck there. The climate was pretty much the same, at least in terms of the amount of water getting into these wetlands. And they were basically sedges and sphagnum moss. But just in the last 150 years since the end of the Little Ice Age, now the trees are rolling in, and since the 1970s, the shrubs are rolling in. So I would say to people, well, okay, why this may be the normal order of things, but why were we stuck at step 6, you know, for 14,000 years? Well, you know, the reason is that the climate was pretty similar, and that it has changed a lot, you know, in the last, say, 150 years. So we'll talk a lot more about that, but that's kind of the general theme. Well, here is an example of a blanket bog that has grown over the water here and up the hill. And these are kind of nasty situations. This is another variation on this. I mean, we have things like this on the Kenai, and they're really quite dangerous. You can come up to a lake and you can see all this nice sphagnum moss is growing out there on the lake, and maybe there's some, might be interesting flowers or something you want to collect. But you want to have a stout stick in hand to probe your way along there, because the lake edge can drop off quite sharply there, and there is this floating mat, and when you step on it, you punch right through it. You know, it can be over your head, so be careful when you're around these things, and have that stick to probe. Well, in places like Ireland, where there is all the precipitation, you can actually get this raised bog situation. And this is common in Minnesota as well. There are many of these, and oftentimes the raised bogs are forested. You know, they dry out. Now, sphagnum, as we'll see, can store a lot of water. So it can actually raise the water table. Now, in this particular diagram, the water table is shown, you know, horizontal, but the truth of the matter is the water table has actually been pulled up here, you know, by the sphagnum moss. So it's standing higher out here in the center. And here is an example from Wales, which is another wet neighbor of Ireland. This doesn't show the domed effect, but this is definitely higher. This would be higher by maybe you know, 3 or 4 feet than the edge here. And there would be a kind of a moat. This is not visible on this, but typically these raised bogs have a moat, which is called a log, L-A-G-G, around them. Well, now fens, on the other hand, can pop up anywhere there's just enough of a little depression and a water source to get some vegetation growing well. So here we have kind of Kenai type examples. So, well, this is shown on a limestone plateau, which we don't have the limestone, but we certainly have springs around here, like this situation over here. This could be a discharge slope where groundwater is flowing near the surface, but below it a bit, and then it's coming out down here at the base of the hill. Or here's a little stream gully that could be have vegetation growing in it, or on the floodplain there could be old meander scars or something like that, where the vegetation can get going. So we have our fens perched around in quite a variety of different places. Well, okay, so here is the fundamental principle of peat formation, and that is that the rate of vegetation accumulation has to be greater than the rate of decomposition. So ask yourself, why isn't peat accumulating in your front yard? I mean, you've got litter there. I mean, if you mow the lawn at all, you've got, grass clippings and so forth. There's leaf litter, and so you've probably got, maybe an inch or so of litter there. But it's only a few years old at the most, and it's decomposing. It gets refreshed every year, but essentially it's decomposing faster than it is accumulating, and that's why you don't have peat. But when you go out in a wetland, on the other hand, well, which is wet, and that, as you'll see, is the big help. The rate of decomposition slows way down, and accumulation can exceed that, and so you get, peat growing in thickness. Well, peat has two basic layers, and we will see this when we get out and start doing some probing and whatnot. There's the live layer up on top, where the roots are there, and the roots are alive, and so forth. And then, that might be 6 to 12 inches thick, and then you dig down a little further, and you come into this layer where things are mostly dead. I mean, there might be a horsetail root or something like that has gone down and rooted in that, but essentially you're just looking at dead plant material, and that's called the catotelm, as opposed to the acrotelm up here. So the chemistry here is really quite different. I mean, up on top there in the acrotelm, things rust. It's an oxidizing layer, and there's free oxygen in there, and if you put a knife in there, it would rust. But further down, on the other hand, it's an anaerobic environment. There's methane there, but no free oxygen. So if you buried the knife there, it wouldn't rust. Okay, so I want to tell you now kind of how we explore some of these things, and we'll have a chance to do some of this, but these guys are taking a peat core here, and they're using a piston core here. And here is another example. Now, basically, a 3-inch tube is being punched down into the ground. It's got serrated teeth at the bottom, so you rotate it back and forth so it'll cut through the roots and so forth. But it has a piston that, when you start off, is tied the piston is right at ground level. So that's where the piston would be in the tube. And then this piston here is being pushed down into the tube. Or pardon me, the tube itself is being pushed down around the piston. The piston is staying fixed right here, and it's staying fixed because it's on a cable that is tied up here at the top of this tower. And so the tube is pushed down around the piston, and that piston holds the suction so that when you take the tube out of the ground, the peat doesn't all fall out the bottom. Okay, so in this case, we've taken the tube out and we have pushed the peat out, extruded it on a board here, and then taken a knife and split it in half. It's about 3 feet long. And then they're measuring some of the things in here, maybe the volcanic ash layers and things like that are being noted. Well, when you start this off, you dig a little hole and you pull out a plug. And that's, let's say it's the height of a shovel, 12 inches or something like that. So here are 3 different plugs that have been pulled out, and then they've been split with a big bread knife here. And you can see, I'll take this one, for instance. This is the acrotelm up here, the living part, and now we're getting down into the catotelm here. And here's a volcanic ash layer in that catotelm here. But this is the oxidizing part up here, and this is the reducing part. So there's the soil plug up on top, and then in this particular place, we've taken out 3 cores, each about 3 feet. So, we're looking at about 10 feet of peat here. And a radiocarbon date down here, the bottom of the peat, the basal peat, indicated that's about 14,000 years old. So this is a fairly typical situation. And then down here, we have sediments from that original pond. They're often blue, which is a rock flour from the glacial period. Probably a Growing Lake. So the sediments in Growing Lake would probably look like this. And it's sort of silt-sized particles, but usually pretty unweathered material. And then there's this kind of gradation zone here where this is probably the fish poop and the Gitya phase before the larger plant material starts to accumulate. Well, the surprising thing was when we took a number of these cores that we didn't find any dead wood down in there. It's pretty much all sedges and sphagnum moss. There's really only one place near Anchor Point off the North Fork Road where we found wood there. So that was the case where there was a forest that got polutified, and that happened about 10,000 years ago when alders first came in. So that was probably an alder forest that got started there, but then the sphagnum took over and buried it. Well, the fact that we don't find wood there is very important because organic material preserves very well. So here we have really a classic bog mummy. This is from Denmark, but Ireland has many of these bog mummies as well. And the radiocarbon date here indicated that this person was buried about 2,300 years ago. I noticed that really the phenomenal degree of preservation here. I mean, you can see all these wrinkles, pores on the skin. So the body is extremely well tanned here. Fens and bogs typically have a lot of tannins in them. The brown color of the water is due to the tannic acid. And tannins are produced by plants as a defensive compound. Basically, tannins bind proteins into an insoluble lump, shall we say. So when a bug eats a leaf that has a lot of tannin in it, it messes up the bug's digestion, and it can't digest the leaf that it just ate. And we see the same thing. I mean, why do you put milk in tea or coffee? Well, you're adding some protein in there, and that protein complexes with the tannins and forms a lump in your stomach that will go through undigested, but it prevents the tannins from upsetting your stomach. So, tannins are a very useful thing for a digestive purpose. But this mummy is an example of just, how well tanned, human tissue can be in that tannin-rich environment. Now, there's also an indication here of how this person died, a rope around his neck. So he probably got into trouble of some sort there. The cultures, that have these bog mummies, they had cemeteries and normal burial practices and things like that. I mean, these are not normal burials. These are problematic people that are being disposed of in out in a peat bog. Well, okay, so when we take these soil plugs here on the Kenai, what we see is that the woody material is all on top. The roots, the shrub roots, are right up there on the upper surface, and basically we are now dealing with allogenic succession rather than autogenic succession. Climate change has come in now and changed that. So things, that for 14,000 years were stable and just accumulating sphagnum and sedges and so forth, now are accumulating crowberry and blueberries and dwarf birch and spruce. On the southern Kenai, well, in the central Kenai, black spruce is a wetland species that are rolling in big time into the wetlands. There on the southern Kenai, we have very little black spruce, but we do have, white spruce and blunt spruce, really, which is an upland species. But we see that out in the peatlands here as well, which I find really amazing. These peatlands out here are so dry that the upland species are moving out and colonizing now. So there are some of the shrubs that are moving in to the Kenai peatlands, and we'll talk more about them, but you probably recognize many of them. And dwarf birch is really kind of the leader of the pack here. This guy is an amazing colonizer. So notice the stems are pretty narrow there. We're talking about 1/8 of an inch, maybe a 1/4 of an inch. So here is a stem. I'm not sure what that scale is, but let's say it's a 1/2 an inch or less. And it grew very slowly. You see how close the rings are together here, until right here, this site was fertilized with nitrogen and phosphorus, just normal garden fertilizers. And you can see, wow, look at the size of the next ring here, compared to these guys. I mean, this thing really took off. So the stem is 15 years old here, but it shows you that these kind of environments are very nutrient poor, and they really respond, to fertilizer. Well, we decided to age some of these stems, and this was kind of tricky. I've done a lot of tree ring work with spruce, you know, things like that, where the rings are pretty large. But here, you know, we're talking about little stems that are 1/4 of an inch in diameter, or maybe a 1/2 an inch if you can find a really old one. And then they are being stained with a purple stain, and then the rings are counted under a microscope. You have to take a razor blade and slice off a little thin disc, you know, stain it purple and count the rings. But we did that, and it was instructive. 3 sites here, 157 rings, and this is a histogram of the ages. So you could see the average age was like 14 years. And I was totally surprised. I mean, I thought these guys would be, you know, a few hundred years old. And no, not the case. They are young. And even they'd all recruited since the 1970s. Well, there was a big drought in 1968 and 69 on the Kenai. And that really kicked off this dwarf shrub invasion, and kicked off the drying of the wetlands very much in general, but this is one of the ones that responded the most to it. And as I say, you know, these are places that had been very soggy sphagnum sedge fens for, you know, 10 to 14,000 years. So allogenic succession now is taking over.
Ed, could I pause you for a moment? I just want to make sure we have 10 more minutes. So I don't know if you want to go through a couple more slides, or if you'd like to open it up to Q&A at this time. Make sure that people have some chance to ask questions.
That would be fine, sure. If we have questions, we can certainly do that.
Okay. One of the questions we've been getting in the chat is more about access to permission of the file. So I just want to let everybody know that that file is hosted on our shared drive, and we will invite you to that shared drive if you want to drop your email privately to me in the chat, or go to our website, homerdrawdown.info, and sign up there. And we can be sure that you're invited to access that file through the drive. So at this time, maybe copy and paste that link. I just want to also remind people that our monthly meeting is coming up on May 20th, and that the next in this workshop series will be Wednesday, May 12th. And then the next one will be on June 2nd. So I just wanted to let people know. Okay, with that, we have a question from, let's see. Okay, so somebody asks, can we stick around to hear Ed finish his lecture after the question? So this session is these sessions are only for 1 hour, and I think out of respect that people sometimes don't have a lot of time, we're gonna continue this slideshow during the next session on May 12th. So keep your eyes open for that. I think it's fine if folks want to stay on a little longer for questions. That would probably be fine with most of us. Jeannie Parker asks, can you talk about Kelvin and Coyle Trail?
Yeah, Kelvin and Coyle Trail is a great example of polludification of a wood. Sphagnum is starting to grow there in several spots. But that was an old growth, Lut spruce forest. And then the bark beetles came and killed really all the big trees. And there was a little bit of logging in there, but more to the point is the trees died and they stopped transpiring water. Now trees can pump out a lot of water. And if you've ever, tried to grow a little fruit tree or something like that, I mean, you have to keep those trees watered. Well, spruce trees can pump out an enormous amount of water, and when they don't pump it out, the water accumulates on the surface. And most of that Kelvin and Coyle Trail is pretty flat and not well drained. So it became very boggy and very wet. It became polluted, and mosses are growing in there now. And as I say, I've actually seen sphagnum itself popping up in a few places. So the question is, will the forest grow back and stop the sphagnum and return to a normal forest? Well, we'll just have to keep an eye and see. I mean, there are small spruce seedlings in there that are recruiting, and if they can get enough of a foothold, maybe in time the forest will grow back and whatnot. But on the other hand, if the sphagnum gets ahead of it, the place might well become a sphagnum area. I mean, it's getting water from further up the slope. Both surface runoff and I think near surface groundwater moving down. So there's plenty of water coming into that site, and my conjecture is that the sphagnum will spread and the pollutification will continue.
Thanks, Ed. We have a lot of questions rolling in. The next one is from Katie. Is sphagnum moss a defining characteristic of peatlands, or can you have peatlands where the peat is made up of more of other plant material?
Oh, indeed. I mean, you can have peat that's entirely sedge peat. There's woody peat in certain areas that one sees. In the salt marsh kinds of areas, there are salt marsh type plants that are forming the peat there. But in these sort of boreal, very northern habitats, sphagnum is kind of the dominant theme.
Great. Our next question from Margie. Are hummocks a sign of former wetlands, peatlands?
No, hummocks are just areas that where the peat has grown faster there, and you typically get sphagnum fuscum, the brown, very densely packed peat moss growing there. But it's very effective in pulling up the water table, and so even though the hummock is a foot or 2 feet high, it's still wet inside because it's got this remarkable wicking capacity. That's been a question that has been looked at with cores, because you can get there's the hummock, that's the high point, and then there's the swale, and different species of sphagnum live in those two different environments. So if you take a core, let's say you go down, you start in the swale and you go down 10 feet and whatnot, well, you'll see that those hummocks can move around. It isn't all swale species for the whole 10 feet, I mean, part of that may be the hummock species. So, on a scale of thousands of years, those hummocks shift around, shall we say, and exchange places with the swales.
That's really interesting. Our next question is from Satchel. Where does the term muskeg come from, or what does it refer to?
Well, I don't know, Satchel, that's an interesting question. But, muskeg is kind of a colloquial term that we use around here for, wetlands of any sort. And I don't think it has any precise meaning at all. But if you're not sure whether it's a bog or a fen, well, muskeg is a pretty good term.
Great. Kyle asks, are there any other species of moss involved with the formation of peatlands? And if so, are any involved in peatlands in the region?
Oh yeah, no, there's a whole group of non-sphagnum mosses called brown mosses, and Drepanocladus, for instance, is one of those. And I'll show you um, down the line some slides of these, but there's a fair number of brown mosses. But there are also many species of sphagnum as well. And I guess I'd say sphagnum is kind of the dominant peat forming moss. Yeah, and we'll see other ones in the field too, for sure.
Okay, great. This next one is from Monica, and the Clat Bog is behind my house in Anchorage. I'm wondering whether it is actually a fen. And I used to live in Juneau and love the muskegs there. Are they also probably fens or bogs?
Well, I don't know that specific one in Anchorage, but it's a pretty good bet that is a fen. I mean, Anchorage is even drier, than Kenai and Sultan, and I would pretty well bet that that's a fen. But the ones in Southeast, that's the opposite situation, where you've got plenty of rainfall, and many of those would definitely be bogs. Yeah.
Great. We have a few more questions. It is 7 o'clock, but I figure if folks want to stay on the line, Ed, would you be willing to stay on a little longer and answer some more questions?
Yeah, I would. Now would encourage people to look over the PowerPoint slides. This is version 1. It'll say, V1, but I will be adding to it, and maybe by the time the next talk comes around, there'll be version 2 or 3 on the line. But that's sort of the way I work on these things. I'm always kind of updating them, but we'll always have the latest version on the website.
And a bunch of people sent me their email in the chat. That's great. I will make sure to invite you to our shared drive, which is where we are hosting all of our file resources for this project, including like a PDF of that sphagnum guide that Ed shared, among other things. So I will invite you to that, and I'll just let people know that this information will be in the file that is the community science and surveys file, if you get lost in the drive. Okay, and you can always reach out to us for questions if you have them. So the next question is from Seal, and actually she's got kind of a two-part question. One relates to is sphagnum moss a keystone species for peatlands? And I know you talked about that it's not the only type of vegetation, but that may be a different type of question. And then she also asks, do different types of peatlands sequester carbon at different rates?
Keystone species. Well, I would be inclined to say that it is a keystone species, because it structures the environment. A few slides down, I talk about acidification, and sphagnum has the remarkable capacity to acidify its environment. In other words, it makes it hostile for plants that don't like very acidic environment, which is most plants. And as far as I know, sphagnum is the only one that has this remarkable capacity. And I'd say, because of the fact that it can kind of build its own environment to suit itself, that it pretty well sets the stage for everybody else. And to me, that would make it a keystone species. Now, seal might have a different concept of keystone species, but that, this is how I would kind of argue that. Like, and can you repeat the second?
Yeah, the second question was, did different types of peatlands sequester carbon at different rates?
Well, I don't know enough about the full range of peatlands to answer that question well, but I will say that the local climate very much determines the rate of carbon sequestration. Well, and let's say site factors as well. I mean, how well hydrated the site is. I mean, if it's well hydrated, okay, the peat can accumulate much faster. But if it's kind of poorly hydrated, plants aren't going to grow as fast, and carbon won't be sequestered at the same rate. So, in terms of what's going on in the Kenai, I'm much more interested in site differences like that. Should we say that than I am, different species of sedges and sphagnum that might be involved.
We have more questions in the chat, which is great. There's some great ones. But I also realize that some people may not have this chat option or be familiar with how to use it. So I just wanted to put it out there right now. If there's anybody who wants to unmute themselves and ask a question because they don't have access to this chat, maybe I'll give that a couple seconds before moving on to the next one. Okay. So I like this one from Katie. Okay. When just coming across a peatland without being able to see the water source, are there easy ways to distinguish a bog from a fen?
Well, a real bog, is pretty much dominated, just by sphagnum, and you won't see much else growing there. The species list, is just very short in terms of things that can tolerate that very nutrient poor acidic environment. Now, I will say on the Kenai, sometimes you can see fens that are a little bit raised in the middle and a bit drier, and just have sphagnum growing there. And they are really bog-like. They they wouldn't be considered really a true bog, but they have kind of grown as far up as water can be pulled up by capillary action and so forth, the wicking effect. So now they're depending more on rainwater, really, than what they're able to wick up, from groundwater. And that's where you would look for kind of the bog-like effect there. But if you went to southeast, on the other hand, you could find large areas that looked like that, that were dependent on the rainwater there, and were not well fed with minerals. But here it's just a very localized condition on top. And underneath, we're looking at sedges and sedge peat and sphagnum peat and so forth that represent the fen environment.
Thanks. I think that's really fascinating that you can use the plants themselves to see what is going on underneath. And I just want to let you know it's a little hard to hear your audio just recently, so I'm not sure if maybe you could speak a little closer to the mic. Okay, this one is from Devaney. Does Seward, with its wetter climate, have real bogs rather than fens? So we've, yeah, got similar questions.
Yeah, I would think so, but I really don't know the Seward area that well. I don't know, I'm embarrassed to say, but it certainly got the precipitation that could support bogs, and I'm sure that there must be some bogs there. Yeah, be fun to look.
Okay, this next question is from Seal, and it's, at what point do peatlands start releasing methane as opposed to storing carbon?
Well, peatlands typically are storing carbon through plant growth and accumulation. But they are losing methane, coming up from the subsurface. So well, Patty Sullivan has just gotten the flux tower up and running east of Sterling, and it's
Hey,
showing.
Ed,
Yes.
I'm sorry to interrupt you. We're getting a lot of like scratch. Is there anything that's rubbing against your mic or anything? I'm hearing a lot of like background noise from your mic.
Well, the mic is on my laptop.
Okay. I wonder, let me fish around and see if somebody's unmuted. If you are unmuted, please mute yourself. Okay, carry on, Ed. Sorry about that.
I lost my. Oh, okay. I was telling you, we have this instrumentation that is measuring CO2 and methane flux east of Sterling, near Lily Lake, and it's just gotten up and running. So this morning I was looking at the output of that, and I see right now it is off-gassing some CO2, which you would expect at this time of the year. There's not much photosynthesis going on. And it's off-gassing methane as well, which you would also expect. Well, during the summer, I expect to see the CO2 reversed, that the plants will be growing and picking up CO2. But I will expect the methane to continue to outgas all the time. There's really nothing there that's tying up methane. There are bacteria that are eating methane, and it would be great if they ate all the methane, but generally they don't. So there is some methane outgassing all the time, from peatlands. Now this is a sedge area where Patty has set this instrument up, and sedges have a tubular vascular structure, you might say, that allows gases to pass. So the roots of the sedge plant are down there underwater, oftentimes, in the catacomb, and they need oxygen. So the oxygen comes down through these tubes, or parenchymatous tissues, it's called, to the roots, which is fine. But then the methane leaks out through these same tubes. So you can get, more methane coming out of this sedge than a stagnant one. So I'm expecting, when the ground thaws out well, that the methane output, will increase. But as I say, there's nothing that is tying up the methane. I mean, it's either if the methane eating bacteria has not consumed it, it's going to escape. But the CO2, on the other hand, is being taken up through photosynthesis. New plant tissue is being created, and that carbon, is being sequestered. But of course, there's the dead plant material, and that's being oxidized, and that's, giving up carbon as CO2. In the wintertime, you can expect that's going to be the process. But sometimes, when the ground thaws, so I expect to see the CO2 reverse on the site, and the plants start tying up the CO2.
Okay, Ed, I think we should probably call it for the evening. We didn't get to everybody's question, but I just want to let folks know that I dropped a link in the chat there. This is our Slack channel, which is an online discussion forum, which is great to have further discussions on exploration, share articles. And also, if you have not been receiving our updates and emails, please do sign up at drawdown.info. And Ed, I just want to say thank you so much for all your incredible knowledge and for carefully answering so many questions. And we look forward to seeing the continuation of this and moving on towards what looks like sphagnum here on the next slide.
Good, great.
And you have lots of people sharing in the chat. Thank you. And this was a great program, and they look forward to more. I'll also get this recording up on the website, hopefully soon. So if you missed some of it and you want to review it, it will be there.
Thank you, Kim.
Yeah, thank you, Ed. If you want to hang on the line a little bit, that's fine too. I'm going to stay and I'm going to copy and paste everybody's email from the chat to make sure that they get access. So I just want to say, Sue Christian says, thanks, Ed. So appreciate your expertise. Carol, thank you very much. Monica, super great program. Kyle, thanks for your time. Seal, thanks, Ed. Very interesting. Katie says, thanks so much for sharing the knowledge, Ed. And thanks, Kim, for being an excellent host facilitator. Thank you. Elizabeth says, Ed. Rika says, thanks so very much. Kim, you're great. Ed, you're phenomenal. So if we were in a room all together, everyone would be clapping and cheering.
Maybe we'll be in a room someday.
I hope so.
It's coming.
It's coming soon.
Here we are.
Okay, is Satchel around? I might ask.
Yes, I am.
Hi, Satchel.
Hi.
Is there an easy way to copy in the chat thread?
Oh, yes, there is. I believe, let's see. Everybody always has to tell me how to do this, so I'm not the best person to ask.
Okay.
If anyone still here knows. There is, I know that there's an easy way. I don't remember what it is. Hold on. Let
Okay,
me
I'll
explain
look
it.
around here and see if I can.
Okay, I think in the chat box on the right hand side, there's the three little dots, but next to that it says file for me. And I think you can save that to your Google Drive or any other place you like.
Do you see that? So on the little like chat icon down on the bottom, because I
Well,
don't.
like within the chat box itself.
Oh, okay.
I'm seeing if it works. I'm not sure yet.
Oh, save chat.
Oh, that's probably the right one. Huh?
Chat saved. Okay. It looks like it got saved in my personal folder, which is, ooh, it looks really crazy.
Oh, no.
But it's there. It's there. It's like old school, like Type font. Okay. All right. Excellent. I just want to make sure that everyone who popped their email in that chat gets invited to the drive.
Yeah.
Mhm.
Yeah, I'm not sure if what I was doing was working.
Ed, I'm sorry I called you a wildlife biologist. I know you're an ecologist. I just had an overwhelmed moment of hosting there with a lot of information coming out of my brain to my mouth.
Yeah, I also called you a climatologist. Sorry about that, but you're everything.
I wear many hats.
Yeah.
He can be those things too. He knows lots about that stuff. Wow, this was fun. I'm looking forward to the other ones, and we'll kind of see what happens if we get ideas for any more for the summer, or if we kind of want to wait again until the fall. I think it would be really fun to continue on with this, especially if we could actually meet like at the lab at the college and do things like, you know, plant labs or peat carbon content labs or other fun stuff like that. Sketching labs.
Well, we've talked a bit about that. We just haven't got anything nailed down.
Mm-hmm.
But, yeah, a plant of identification spot, where people could bring their plants. We'd have some microscopes and some keys, and
Mm-hmm.
I'd be glad to come in and consult with folks. And,
Mm-hmm.
yeah, it could be a terrific learning opportunity.